Good morning, my dear friends. See now in this second problem, I think we have completed this A part. In the sense, he has asked you to find out the principal tension at the centroid of the section. That we have done it. Now what he has asked is B. What is the vertical pre-stress required to reduce this principal stress to 0? Okay. So now see now, Baba. In the last this thing, what we did was, okay. Please try to understand. Principal tensile stress at CGC is minus 0.984. Okay, so now, Baba, you calculated your sigma x so much, okay, and tau v you have calculated, and since okay, Baba, now vertical pressure is absent, sigma y is equal to 0. So by using all this data, you have calculated your principal tensile stress. It was so much. Okay. Now in the second B, what he has asked is, okay, if at all I want to make this principal tensile stress to 0, okay, how much is the vertical pre-stressing required? How much is the vertical pre-stressing force required? That's what he has asked. In the sense, when okay, understood or not now? So now, let us see now what to do now. Let sigma y be the vertical pre-stress required to reduce the above principal tensile stress to 0. Okay, sir. Now, in a sense, this should become 0. So when this should become 0, how much your sigma y should be? That's what he is asking. Okay, see now. So now, in the above data, your sigma x was 7.69 Newton per m square, and tau v was 2.93 Newton per m square. Okay, so now you know that principal tensile stress is given by this equation. FCT is equal to sigma x plus sigma y by 2 minus this much. Okay, now you know that this principal tensile stress should be now equal to 0. Okay, so now I will equate it to 0 now. Okay, now I have kept everything same. This and this are same. So now, or I will take now, I will take this term this side. Okay, because it's minus, it will become plus. Okay, so sigma x plus sigma y by 2 equal to this term. Am I right now? Or by squaring, I will square both sides so that this root will go. Okay, so it is sigma x plus sigma y by square whole square. If I square 2, it will give me 4 equal to this as it is. If I square it, this square root will go now. Okay, so now, but now you expand this sigma x plus sigma y by 2 whole square, a plus b whole square, sigma x square plus sigma y square plus 2 sigma x sigma y. I have expanded this. This 4 I have cross multiplied here now. Okay, if I take cross multiply here, 4 will get cancelled. Okay, and I'm again sigma x minus sigma y whole square, a minus b whole square. That expansion I have kept. Okay, and this 4 will become here tau v 4 tau v square. Just I have simplified it. Okay, now here sigma x square will get cancelled with this sigma x square, sigma y square cancel with this sigma y square. Am I right now? And I have been left with this much. 4 sigma x sigma y is equal to 4 tau v square. 4 also will get cancelled. So sigma y equal to, I can write it as tau v square divided by sigma x. Okay, so now this is the equation. Okay, sir, now if my principal stress should be equal to 0, then I need sigma y is equal to so much, tau v square divided by sigma x square. Am I right now? So now, Baba, in this equation, I know tau v because just now you have written. Okay, in this equation, tau v value I know, sigma x I know. Just fill up. Tau v I know, sigma x I know. Okay, if I fill up those things, tau v I know, okay, sigma x I know. Okay, sigma y becomes 1.12 Newton per m square. In the sense, if I apply 1.12 Newton per m square as my vertical pre-stress, then now your principal tension is going to become 0. That is what is the meaning. Okay, now third point what he has asked is to find the principal tension when vertical pre-stress of 800 Newton is applied. Okay, in a sense, suppose if I apply a vertical pressure of 800 Newtons, okay, then how much is the principal tension he has asked. Okay, so now let us try to see now how it can be now solved. See now spacing of the vertical stirrups is given by this equation. This one equation which is there in IS code. Okay, spacing is equal to ASV FSV divided by sigma y b, where S is the spacing of the vertical stirrups, ASV is the cross-sectional area of the stirrups, FSV is vertical pre-stress applied to the stirrups. Okay, that is FSV. Sigma y is equal to, sigma y is here, sigma y is equal to vertical stress in concrete. Okay, so now B is equal to breadth of the beam, as you know. Okay, so now, Baba, from this equation, I want to calculate now sigma y. Okay, I will just rearrange it. Sigma y is equal to ASV FSV divided by SB, where S is now spacing. See now, in this problem, he has given the spacing S. Okay, spacing S is 200 mm. Breadth B, as you know, breadth of the web B is 600 mm. Okay, and ASV, now ASV is, Baba, in the problem he states that he is going to use 5 mm 5 wires. Okay, area of 5 mm 5 wire into 2, because it is 2-legged vertical stirrups. Okay, into 2. So it will give me so much. Okay, FSV is 800 Newton. Okay, so now I think from this you can easily calculate sigma y. Sigma y, ASV I know, it's here. Okay, ASV I have put. FSV I know it is 800. Okay, spacing is given in the problem, 200 mm, and the breadth B of the web B 600 mm. So by doing this, I will get vertical pre-stress as sigma y. Okay, so now, Papa, in your previous thing, we have obtained sigma x is equal to so much, tau v is equal to so much, and now you have obtained sigma y is equal to so much. For these things, what is the principal tensile stress, FCT? Baba, you can easily calculate. You know sigma x, you know sigma y is here, divided by 2. Tau v also you know, tau v is now here only. Baba, fill up this and get the value of principal tensile stress, FCT. Okay, this is what he has asked. And the last thing what he has asked is now, Baba, to find out the required spacing for item B. Baba, item B was, as you know, item B was, see now, item B was to find out the vertical pre-stressing force. Oh, sir, now, to make this FCT equal to 0. Am I right now? So now, for this case, he has asked you to find out this thing now, spacing. Am I right, sir, now? See now, how to calculate the spacing, we'll try to see now. So now, if FCT is to be 0, then the required sigma y is equal to 1.12 Newton per mm square. This you have already calculated in your case B. Okay, let us assume that, Baba, we are going to use 2-legged vertical stirrups with 5 mm 5 wires. Okay, so now, and let us assume that vertical pre-stressing applied is 800 Newtons. Okay, so for this data, I want to find out the spacing. Okay, let us try to find out the spacing. See now, spacing, as you know, just now you saw now, spacing can be now easily calculated by the equation S is equal to ASV FSV by sigma y b. Okay, Baba, ASV you know, ASV is the area of the stirrups. I am using 5 mm 5 wires, so it is pi by 4 into 5 square. Since it is a 2-legged into 2, FSV you have applied a pre-stress of 800, sigma y you know 1.22, okay, and breadth B is 60. So now it will give me 468 mm as the spacing, or say 450 mm as the spacing of the stirrups. This is how, Baba, now this problem can be now solved. Baba, this problem is little confusing and little lengthy also. Please try to go through it once again. Okay, thank you very much. We'll stop it now. Thank you.